From space, Venus looks calm, a bright world hidden beneath thick clouds, shining as one of the most visible objects in our night sky. For centuries, people believed it might be similar to Earth, a warm planet concealed under a blanket of atmosphere. But those clouds hide one of the most hostile environments anywhere in the solar system. On the surface of Venus, temperatures reach nearly 860 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is about 90 times stronger than Earth's, comparable to being nearly a mile beneath the ocean. Above it all, thick clouds filled with sulfuric acid block most sunlight from reaching the ground, trapping heat and turning the planet into a runaway greenhouse world. Nothing we had ever built was designed to survive a place like that. Yet during the height of the Cold War, the Soviet Union decided to try. They would attempt something no one had ever done before: to land a spacecraft on the surface of Venus. At the time, no one knew exactly what conditions waited below the clouds. The atmosphere was impenetrable, the pressure uncertain, and every attempt to study the planet had ended in failure. But Soviet engineers kept going. Mission after mission was launched, each one descending deeper into the planet's deadly atmosphere, each one destroyed before reaching the ground. Until finally, after years of failures, one of those machines made it all the way down. And for the first time in history, humanity saw the surface of Venus. The Soviet Union began its attempts to reach Venus in the early 1960s with a series of spacecraft known as the Venera program. At the time, Venus was still one of the great mysteries of the solar system. Scientists knew the planet was covered in thick clouds, but no one knew exactly what existed beneath them. Some believed the surface might be extremely hot, while others thought the clouds could be hiding oceans or even conditions similar to Earth. Getting a spacecraft to the planet was already an enormous challenge. Early missions struggled almost immediately. Rockets failed during launch, guidance systems malfunctioned, and several probes were lost before they could even leave Earth's orbit. Space exploration was still new, and sending a machine millions of miles through space pushed technology to its limits. But even when the probes did reach Venus, the real problem began during the descent. As the first spacecraft entered the atmosphere, instruments started sending back data showing that conditions were far more extreme than engineers had expected. The deeper the probes traveled, the hotter the environment became. Pressure increased rapidly, and the thick atmosphere slowed the descent in ways that were difficult to predict. Within minutes, many of the early spacecraft stopped transmitting. Some were crushed by the pressure. Others overheated before reaching the surface. Several simply went silent, destroyed by conditions no probe had ever faced before. Each failed mission revealed another piece of the puzzle. Venus was not just difficult to reach, it was a world that seemed determined to destroy anything that tried to land there. And with every new probe, the data coming back made one thing clear. If the Soviets wanted to reach the surface, they would have to build something far stronger than any spacecraft ever made. As more Venera probes entered the atmosphere of Venus, the data they transmitted began to reveal just how extreme the planet really was. At first, engineers expected the temperature and pressure to increase gradually during the descent. The probes had been designed to survive harsh conditions, but nothing far beyond what spacecraft might experience near other planets. That assumption turned out to be wrong. With every mission, the numbers coming back from the instruments were higher than predicted. Temperatures climbed far beyond what the early probes were built to handle, and pressure rose faster than anyone expected as the spacecraft descended deeper into the atmosphere. The thick clouds surrounding the planet blocked most sunlight, leaving the lower atmosphere dim and hazy, while the dense carbon dioxide trapped heat with nowhere for it to escape. By the late 1960s, the picture had become clear. Venus was not simply a hot planet hidden beneath clouds. It was a runaway greenhouse world where heat built up faster than it could escape, creating conditions unlike anywhere else in the solar system. The deeper the probes traveled, the more hostile the environment became. Electronics failed, structural parts weakened, and transmissions often stopped long before the spacecraft could reach the ground. For the engineers working on the Venera program, this discovery changed everything. Reaching Venus was no longer the hardest part. Surviving the descent and landing on the surface was. Once the true conditions of Venus were understood, the challenge changed completely. The problem was no longer how to reach the planet. The problem was how to survive it. A normal spacecraft would never make it to the surface. The pressure alone could crush most probes before they even reached the lower atmosphere, and the intense heat would destroy electronics within minutes. If the Soviets wanted to land on Venus, they would have to build a machine unlike anything that had ever flown in space. Engineers began redesigning the Venera landers from the ground up. The probes were built as heavily reinforced pressure vessels with thick metal shells designed to withstand the enormous weight of the Venusian atmosphere. Inside the lander, instruments and electronics were sealed within insulated compartments, protected by layers of cooling systems meant to delay the heat for as long as possible. Even the descent itself had to be carefully planned. Parachutes were used to slow the spacecraft as it entered the atmosphere, but engineers quickly realized that descending too slowly could be just as dangerous as falling too fast. The longer the probe remained in the hot, dense air, the more time the heat had to build up inside the lander. To solve this, later missions were designed to release their parachutes before reaching the surface, allowing the probe to fall the rest of the way more quickly, reducing the time spent in the extreme heat. Every part of the spacecraft was built with one goal in mind: not to survive for hours, not to survive for days, just long enough to reach the surface and send something back. After years of failures, redesigns, and destroyed probes, the Soviets were finally ready to try again. In December of 1970, the Soviet Union launched a spacecraft called Venera 7. Like the probes before it, the mission sounded simple in theory, but was incredibly difficult in practice. The lander would enter the atmosphere of Venus, descend through the thick clouds, and attempt to reach the surface without being destroyed by the extreme heat and pressure. As the spacecraft approached the planet, everything depended on the descent. Venera 7 entered the atmosphere at high speed, deploying its parachute as it fell into the dense layers of gas surrounding the planet. For several minutes, the probe transmitted data as it slowly made its way toward the ground. Then something went wrong. During the descent, the parachute system partially failed, causing the spacecraft to fall faster than planned. Engineers feared the lander would crash or be destroyed before it could send any useful information. But the probe kept transmitting. Against the odds, Venera 7 survived the fall and reached the surface of Venus. For the first time in history, a human-made object had successfully landed on another planet and continued to send signals back to Earth. The transmission was weak, and the lander had been damaged during the descent, but the instruments were still working. For about 23 minutes, Venera 7 sent temperature data from the surface before the extreme heat finally overwhelmed its systems. The mission proved something extraordinary. Landing on Venus was possible, and now that the Soviets knew it could be done, they began preparing a new generation of probes. Spacecraft built not just to survive the landing, but to show what the surface of Venus actually looked like. A few years after the success of Venera 7, the Soviet Union launched a new generation of landers designed to do more than survive the descent. This time, The goal was not just to reach the surface, it was to see it. In 1975, Venera 9 and Venera 10 were sent toward Venus, each carrying cameras built to operate under conditions no camera had ever faced before. The landers were protected inside thick pressure vessels, designed to survive long enough to transmit images before the heat destroyed their systems. As the spacecraft entered the atmosphere, they descended through the same dense clouds that had destroyed so many earlier probes. Parachutes slowed their fall, instruments recorded data, and the landers continued transmitting as they moved closer to the surface. Then, one after the other, the probes touched down. For the first time in history, cameras on the surface of another planet began sending pictures back to Earth. Protective covers were ejected from the lenses, and the cameras slowly scanned the landscape around the landers. Line by line, the images were transmitted across millions of miles of space. What appeared on the screens surprised everyone. Instead of oceans or smooth plains, the surface was covered in broken rock and hardened terrain. Large angular stones lay scattered across the ground, as if the landscape had been shattered and left untouched for millions of years. The sky above looked dim and orange. The sunlight filtered through the thick atmosphere and heavy cloud layers that covered the planet. For the first time, humanity was looking directly at the surface of Venus, and it was nothing like the world people had once imagined. Later missions, including Venera 13 and Venera 14, survived even longer on the surface and returned more detailed measurements. For the first time, scientists could study Venus not just as a distant planet, but as a real environment with its own weather, geology, and atmosphere. What the probes confirmed was even stranger than expected. The thick atmosphere that surrounds Venus does more than trap heat. It also spreads that heat evenly across the planet, leaving almost no difference between day and night. No matter where the landers touched down, the conditions were nearly the same: hot, dense, and incredibly still. High above the surface, winds move at tremendous speed, circling the planet in just a few days. But near the ground, the dense atmosphere slows everything down. The air is so thick that even strong winds move slowly, creating the silent, unmoving landscape seen in the photographs. The surface itself appeared to be covered in volcanic rock, hardened lava, and fractured terrain, suggesting that Venus had once been far more active than it is today. Without oceans or shifting plates like Earth, the planet's heat escapes in different ways, building pressure beneath the surface until massive volcanic eruptions reshape the landscape. The probes also confirmed that the atmosphere is made mostly of carbon dioxide, creating the runaway greenhouse effect that keeps the planet locked in extreme temperatures. Heat enters the atmosphere easily, but once it reaches the surface, it cannot escape. For the landers, this meant there was no safe place to hide. Even with thick metal shells and heavy insulation, the heat slowly worked its way inside. Cooling systems could delay it, but not stop it. One by one, the probes went silent as their electronics overheated and failed. Yet for a short time, machines built on Earth had survived on the surface of one of the most hostile worlds in the solar system. And what they sent back changed how we understood Venus forever. The Venera program remains one of the most remarkable achievements in the history of space exploration. Over the course of 2 decades, the Soviet Union launched probe after probe toward one of the most hostile worlds in the solar system. Many failed before reaching the planet. Some were destroyed during descent, others survived only minutes after landing. But a few succeeded. They reached the surface of Venus, survived long enough to send back data, and showed humanity what another planet actually looks like under conditions we had never experienced before. Join us next time as we explore more mysteries of the universe.